In a previous video, we discussed the purpose of first-hop redundancy protocols. I listed and briefly shared a difference between HSRP, VRRP, and GLBP, all first-hop redundancy protocols. And then we went through and we discussed the theory and the operation behind HSRP. Right? The timers it uses, the priority, how the election process happens, some of its terms. And now, in this video, we want to go through and configure HSRP and verify its operation. So this is where I left you in the last video. The main thing I have to do to configure HSRP is configure a virtual IP address. So I do that by using the command standby, then the group number, the keyword IP, and the IP address of my virtual router. That's all I have to do for each of the routers that I want to participate in the HSRP group. Next, though, I could configure priority, which is optional, but you probably want to do it. It makes your traffic flow a little more deterministic. That way, when I configure a particular router as with the highest priority, that will be my active router. If no priority is configured on all the routers in the group, they'll default to a priority of 100. All of those priorities being equal, the active router then will be the one with the highest IP address. So although priority is optional, it's a good idea to do. The other interesting thing, I guess I'll go down to preemption first, and then I'll discuss what's interesting. The other optional thing that you can do is preempt or preemption. So you do standby, the group number, and then the keyword preempt. What that does is allows that router to participate in any re-election process. So by default, once my router, once HSRP is stabilized and I have an active router, it will stay active even if another router comes on the network with a better priority, unless I configure preemption. If I configure preemption throughout the whole group, then the one with the better priority then, because they would all be allowed to participate in the re-election, they would go through the re-election process, the router with the better priority would win. Without preemption, its default action is to say, once HSRP is converged, this is the way we're going to leave it. Also, the other thing why you may want preemption is because if my active router goes down, and I've configured my active router to be active because of a higher priority, if it goes down, HSRP recalculates, right? We take our standby, he goes to active, and we find another standby. If my active router comes back up, because I've purposefully defined him with a better priority, then the likelihood is I want him to then, when he comes back up, become the active router. If I don't have preemption enabled on all the routers in the group, the old active router won't become active again when it becomes available again. So another reason why you want to configure preemption is that my active router goes down, but for the stability of my HSRP topology or my topology, when he comes back up, I want him to be active again, but he won't be if preemption isn't enabled. Interestingly enough, though, if the active router was elected based upon higher IP address rather than higher priority, that won't cause a change in preemption. But if the priority is used, or priority is configured to be higher, then preemption will work with the active when the active router becomes a backup. And we're going to go ahead and look at that. I'm going to demonstrate that because it's a theory thing that when you read the RFP or whatever, you're like, huh, really? So we're actually going to go through and demonstrate that. Let's go to the next slide. So this is the topology we're going to work with. Basic, simple topology. Saw it in the previous video. The main difference here is I'm calling out my virtual router IP, this guy here. Okay, so let's look at the purpose again. Let's just revisit the purpose of first-hop routing protocols or redundancy protocols, and in particular, we'll look at HSRP. But here, generally on a host, I can only assign it one default gateway. That's true of everything in IT. I believe in, you never say never and you never say always. There's always exceptions to the rule, right? You're sitting on a host and you generally configure an IP address, a default gateway, subnet mask kind of thing. And you configure one default gateway. So if I configure this host to use the 1.1 default gateway, that's fine. He wants to get to 10.10.1.1 somewhere outside of our network or past the subnet that he's at, that's fine. He's going to go up through here and go there. And just as a reminder again, remember default gateways are used by hosts to get off of their subnet. This guy, regardless of what the default gateway is, in fact you wouldn't even need one, could get to 1.1 without a problem and 1.2. It's just getting through them and getting onto a different subnet that it couldn't do. Now what happens if this link goes down, host my host, in order to get to 10.10.11 or to get off its subnet, whether it's this address or any other address off its subnet, it still needs to use this default gateway. That's what it's configured to do. So it goes there and realizes, that's gone. Packet's just gone. It's in the abyss. It's been dropped. When we configure our virtual router, what we'll do is we will point the default gateway. We will make the default gateway .3. And the active router will service all packets destined for 1.3 with the virtual MAC address. So anything destined for the virtual router will go to the active router. So if this guy starts out as active, let's go ahead and erase our ink real quick. Let's say this guy wins the election process, either through priority. Actually, he wouldn't win through a higher IP because he's got a lower IP address. But let's say we've set his priority at 110, so he becomes active, he becomes standby. Fine, traffic flows perfectly, goes to where he needed to go, and then he goes down, right? HSRP fails over and says, okay, well, now this guy's active. My host, he doesn't know anything because nothing has changed. He wasn't hard-coded to be 1.1, and he's not hard-coded to be 1.2. He's hard-coded to be the virtual router. The new active router takes over the role of forwarding packets that are destined for the virtual router. So now packets just simply go this way. Our hosts in our network are none the wiser. So let's go ahead and configure that. Well, before we do that, let's verify that what I'm saying is true. I know you guys all believe me, but I like to show you. Sometimes I forget, but that's how I like to do things. So I want to show you that this is actually true, that routing will not take care of this initial problem without a redundancy protocol. All right, so I brought my window back over. Let's do an IP config. And we can see, okay, our host is 1.10. We use the default gateway for router 1 is 1.1. Right now we should be able to ping 10.10.11. And we can. Now if I shut down the interface for R1, failover through R2 can be provided for everything else, for routing, right? But my host still sends all its packets to 1.1 because that's its default gateway. That is how the host is instructed. If it wants to send something off of its network or off of its subnet, has to go through 1.1. So I'll go ahead and pull the console over. Yeah, we do. And both of them are 0, 1, or 1 interfaces. So on both routers R1 and R2, we're going to go ahead and shut this one down. Okay. You see we lost our HSRP connection. That's just the routing protocol I was using in this little network. Now let's go ahead and bring our command prompt back. It's mad at me. There we go. Let's bring that up a little bit. And let's hit the up arrow and go ahead and try to ping again. And it doesn't work. That's what we plan. That's what we know. I just like to demonstrate and show, hey, it's not going to. Routing is redundant. Routing will find a new path. But the host at this point still wants to send everything to its default gateway because it's a computer and it does what I told it to do, right? All right, so let's go back and let's configure HSRP. Just to bring it back up for you. Now we're back up. And I did I do a shut? Let's go back. Did I remember to do a no shut over here? Let's go back and bring this guy back up. And then let's go back. Standby. No good reason. I just wanted to let that one converge while I was doing this. Standby 1, IP 192.168. Our virtual router IP address is going to be 1.3. We'll go ahead and do that on R1 as well. Same group member. Okay. And we can see that we are already transitioning through our states. So let's go ahead and show standby brief. Brief's the easiest. We can do show standby as well. What we find out on R1 by doing a show standby is that the priority is 1. It's in group 1. The interface that's participating in HSRP is a gig 01 interface. Again, sorry, R1 is standby. The active router in this topology, or the active, is 192.168.1.2. The standby router is the local router, meaning the router I'm on, and the virtual IP for this group is 1.3. If we do a show standby, we get more information, obviously, because it's not brief. But the other thing we see is what we talked about before, is that it creates a virtual MAC address with the last 2 digits being the group number. We configured a group number of 1, so it's 01. It also tells us that V1 is being used by default, and then when the next hellos are sent and things like this. So this is our information. Let's go ahead, and 2 should be active. Just make sure he's not stuck. Well, we can already see he transitioned from standby to active. Shows standby brief, and he is. And again, same kind of information. Group 1, priorities, the default of 100. The state for this router is active. The active router is the local router, meaning it's this one. The standby router is 1.1, and the virtual IP is 1.3. So now let's go ahead and do our demonstration that we did before. We'll have to do it a little bit backwards just because of the way things turned out. So why don't I go back to my slide to explain that for a second. So back to our topology. If we look at our topology, this guy became active, R2 became active, R1 is now standby. Our previous demonstration, I made 1.1 the default gateway. When he went down, right, we couldn't go anywhere. Now what I'm going to do is, because this guy he's the one currently forwarding for our virtual router, we're going to change our default gateway to 1.3, verify it's changed. We are going to make sure we still have connectivity, and it should go this way in order to get connectivity. Then I'm going to shut down this link and verify that, in fact, we still have connectivity, because that is the point, right, of HSRP, or redundancy protocol. It should then, what should happen then is this guy should become active, and our package should now go this way. So let's go ahead and do that. Let's change our default gateway. Let's shut down the interface for the active router, R2. Let's see that HSRP fails over for us. All right, so bring it back over to my command prompt. I've already changed the default gateway. I suppose I could have brought you guys through that, but I thought if you were at this point, you know how, and make the video faster. So if I just do an IP config, now you see that my new default gateway is 1.3. Let's verify, in fact, that we can still ping 10.10.1.1, and we can. So we still have connectivity into our network on the other side. Now let's go ahead and we'll shut down the Gig 1 interface on R2 and watch HSR behave the way it's supposed to. So this guy's the R2 is the active router. Big T, sorry. Going to the Gig 01 interface, and let's shut it down. Let's watch it go through its states. It's going to take a minute here. He changes from active to init because he's not participating in it. His interface is shut down. And if we do show standby brief, we can see the state. We can tell at this point he doesn't know who's active, mostly at this point because he's not communicating with any other routers in the group. Let's go over to our R1 router and make sure that that router took over. Show standby brief, and he did. So now R2 is the active router. HSRP works the way it's supposed to. We should have no failure as far as our host is concerned. Let's bring our console connector, our command prompt. And we hit the up arrow. Oh, there we go. Just needed to scroll. Hit the up arrow, hit enter, and we can still ping. Should do it again, just because I didn't scroll very well. There we go. HSRP is doing its thing. It's doing what it's supposed to do. Now all I want to demonstrate is priorities and preemption. First, let's go ahead and bring R2 back up. So we do a no shut. Let it form a neighbor adjacency. The IGRP has nothing to do with HSRP. That's just a routing protocol we're using. So if we do a show standby brief, he's going through the states right now. He's in the speak state. Wait for it. There we go. All right, so R2 is going to stay standby. We don't have preemption configured. Let's go ahead and configure preemption real quick. So let's standby 1, preempt. We'll go over to our other router. Oops, sorry. All right. One thing I want you to notice is even though we've just configured preemption, we didn't start a new election process. And if I go over here, let's make an activity that should. So let's shut this down. Actually, you know what? Yeah, we'll shut this one down. Now let's do a no shut. You would think that this would prompt it to say, hey, we've come back up. What was originally our active has come back up, and so even if it didn't notice the change at first, you would think you've noticed the change now. But what you're going to see is that it doesn't. So let's go through. There we go. We go into standby, so we go through it, but he still goes into standby. You know, it just doesn't make sense. So it's going through the process, but he's still standby. Remember what I said earlier? If I configure the priority, preemption will bring this back active. But if it became active because of a higher IP address, it's not going to do that. So if I go ahead and okay, let's start configuring the priorities. Let's make his priority higher than the other one. And as soon as I did that, it became active. But prior to that, when the priorities were the same, but the election process had originally taken place, or R2 had originally won active because of a higher IP address, it didn't go back to active, but it will if you do the priority with the preemption. So I hope that makes sense. I just went through a lot of steps to do something relatively basic. So of course, if you have any questions, feel free to comment, let me know. And I think I covered everything I wanted to in this one. We did simple basic HSRP with just the virtual IP address, right? The default priorities, which then defaulted and had R2 become the active router. Because of its higher IP address, same priority, higher IP address. We demonstrated that, in fact, our host still could get to 10.10.11 when our active router went down. Then I configured preemption to demonstrate that preemption by itself won't cause the previously active router to go active if the election process happened because, or the active router won the election process because of a higher IP address. But as soon as I changed the priority to 110, even though I did a no shut on the router, which should have said, hey, not participating in HSRP, now I am, let's have an election process, because as the preemption says, is I can participate in that election process. But then as soon as I changed the priority on R2, it became active. Preemption said, okay, now I'm looking at the priority. The election says that this one has to be active at this point. So just an interesting little tidbit. I decided real quick that I wanted to write on the last slide on our topology the commands we ended up with. So on R1 we ended up with standby 1, standby 1 is the group number, IP 192.168.1.3, standby 1 preempt, which means that in R1 our default priority ended up being 100. And then on R2 we configured standby 1 IP 192.168.1.3, standby 1 priority 110, so the priority is higher than this one. Even though this one was our active router, we learned that we wanted it to be configured via priority, so our traffic flow is more deterministic. We know that this guy will become active at all times. It goes down, goes into an it if it stays down. When it comes up, goes through the process and will go active again because we configured the higher priority as we demonstrated. And then also because we configured preemption, so we did a standby 1 preempt. All right, that